Shall we start? All good there in the back? Yeah? Okay, cool. Hi. Thank you for coming to my talk today. I was afraid you partied too much yesterday or something. My name is Cristian. I'm going to be talking to you about a very long title, Architectural Patterns for Spring Security You Wish Your Tech Lead Knew. Ooh, complicated, right? So when it says architectural patterns, what do you guys expect in this presentation? Diagrams, right? Like, I hope you expect diagrams because there will be some. Now, who am I? I work at CERN. It's this particle accelerator complex next to Geneva in Switzerland. I come from kind of a computer security background, but now I work with enterprise Java for the past few years. And I'm also a CERN guide, so if you come by CERN, feel free to drop me a message. I will gladly take you to visit something. If that's the only takeaway you take from the presentation, it's amazing. Now, this is how CERN looks like. It's a 27-kilometer ring, 100 meters underground. Well, CERN itself is not the ring, it's just the experiment itself, the biggest one that we have. We have others and so on. They collide stuff in the middle of detectors like these ones over there. Every 25 nanoseconds, we look at them, we understand what the universe is made of and so on. We're not going to talk about that, right? We're going to be talking about more mundane things like, for example, the CERN single sign-on, which I'll be using as an example soon. We're going to be talking about both patterns that rely more on external systems like IdPs, identity providers, right? And internal things in your code that you can do to actually manage all the chaos. But first, actually, it's the first time I'm talking in Greece, and this is an amazing opportunity to share with you the fact that when the LHC was started in 2008, in case you're wondering why security is important, we got hacked on the first day by the Greek security team, right? And it says something in Greek over there. I don't know. It says something about it's flaming the other Greek competitors because they were first to hack us. Of course, this didn't take down the accelerator. It was more about showing that we can overtake some websites and so on. Very silly, but they made their point. So don't mess with Greek security. Right. If you haven't seen the previous talk, actually, there's a link over there at the bottom. You're going to have the slides at the end. So there's another talk on Spring Security, which is more related to, things you do in one application, when to use OAuth server, OAuth client, and so on. Go check it out. It's interesting, maybe. But today we're going to be talking about more distributed systems, about larger systems, why we have, pain when handling these systems, especially when you have multiple identity providers and so on, and how we can solve this elegantly in Spring Security. Do you use Spring Security in your day-to-day work? Okay, so half of you. The rest of you, I'm sorry for you and for this talk. It's going to be a bit difficult. Now, I call this slide Trouble in Paradise. So basically, the ideal scenario is the following. You, as a user, you access your website, you go to the SSO, done, right? You don't have anything else to do. You're super happy about it, your product works and so on. But at some point, you're going to add more things. There's a cart service, an ordering service, whatever you want from your microservices lectures, right? And the problem is also that you might be able to log in with different things, right? You might have an internal SSO, you might have social auth with Google, Facebook, and so on, right? So it quickly gets complicated. You don't know who has the authority to do what. It gets very messy, right? Especially when you build a large system. And one thing that you should look out for is to check if every service in your company or whatever does its own thing, right? Because if it does its own thing, then maybe you should step back and look at the whole picture to actually understand what's going on there, right? Because otherwise, you end up like this IT guy from the stock photo, right? Okay, first, let's talk about external concerns. So multi-IDP things. We have 40 minutes, so I'm going to be, not rushing through it, but let's say we're going to have a alert pace. So we have three ways of handling multiple identity providers. So that means logging in with Facebook, Google, your company, whatever. The first one is multi-tenant client. So this one is something that you can configure in your application in Spring Boot, right? So you just use auth to client, and basically you have this little page saying, do you want to log in with this provider or that provider or whatever? If you've played around with Spring Boot, you know how it works, right? The second one is IDP brokering. So you do the heavy lifting at the level of the IDP, which means at the level of your Keycloak instance, Auth0 or whatever you're using over there. Why? Because, well, there's less moving parts, less code that you actually write to keep things moving, right? And then the third one is for research server, right? So if you want to authorize somebody to do something in your system, maybe you want to let multiple JOT tokens that come from different identity providers access to your application, right? What I would suggest in 99% of the cases is to go for the second one, right? So as much as possible, try to do the heavy lifting of mangling authorities and data from different providers outside of your application, if possible, right? There's plenty of work to do in the application server and in Spring Boot as well, so don't worry. We're going to get to that too. As an example, when you go to CERN and you try to log in, right, there's a bunch of login stuff on the left side. On the right side, everything else is federated by the realm, right? So basically what that means is like if I click Edugain or Google or whatever, I go to, for example, Edugain goes to a bunch of universities that are all connected to CERN in some way. So you can log in with your university credentials to be able to access certain things, right? And this is great. It's called federation, and it's something that you should be doing, especially in large enterprise settings and so on, if you have multiple sources of credentials. Now, in terms of code, if you want to just do multiple IdPs, so to select from your application where you want to go to, it's easy. You just use Spring Starter Security Auth 2 client, and you configure a special Auth 2 authorization request resolver. And basically, you see here that here we have two options. So we have Keycloak and Federation, and there are two different realms in my Keycloak instance. We're going to see exactly how that works in the examples. But it's, like I said, you can use it, but maybe don't. Then we have multi-tenant resource servers. This one, there's plenty of docs about it. We're not going to go a lot into detail because we also don't have the time for that. But basically, do we want to use one thing or the other? Do we want to go one route or the other when a token comes in, right? So basically, you look at the claims in the token, you validate the fact that the token is correct, and then you go down the path that you have chosen. And lastly, the second case that I was mentioning is basically you configure it outside of your app using IdP brokering. So you have, here is the Keycloak screen for identity providers, right? So you have different options. You also can connect to yourself somehow in a different realm if you have users living somewhere else and so on. Try to do that. Now, why is this important? Because, for example, when you have tokens coming from different providers, so the left one is something that comes from Keycloak, and the right one is an Azure JOT token, right? So if you look at the two of them, you see they look very different, right? Because you can put whatever you want in your JOT tokens, which means a lot of work in your application, right? Because you add yet another one, then you're going to have a custom piece of logic. Imagine you have to put it in all your services and all your applications, right? To handle this case, right? So it's not that great because it adds a lot of work for you. So by doing federation, you make sure that all the tokens that you get back resemble the one of the master realm, let's say, of the one which is, let's say, the owner. We're going to have a look at it in more detail in a second. So I have here, something broke because I pressed the button. Okay. I have 4 things running here. So I have an auth client application, 2 resource servers, and a gateway. We're going to get into that in a second because we don't want to overwhelm you with stuff. But one interesting thing is this auth client application. So if I go to localhost 8081, because it's running there, you get this beautiful screen, right? And it says here, I want to log in to either app or federated, right? So I have 2 realms in here. If I log into app, I know that I can log in as 2 different people. Ignore the button at the button at the bottom. We're going to talk about that as well. So I can log in as either as Bob or Alice. So each of them have username and password the same as the account name. And once I log in, if it doesn't stop in a breakpoint, it shows me that I'm Alice and I have these roles. Amazing. And this is the information that I got from the JOT token. Simple, right? Now, if I, however, log in as through the federated realm, I don't have Alice and Bob, I have Jim there. It's a separate guy, right? So if I log in as Jim here, well, there's some stuff missing. Authenticated user, this used to be the username or the name of the person that actually does it. There's nothing there. Why? Because I got the token from another realm, and my application doesn't, let's say, normalize that data, right? So the contents of the token that come from the federated realm look different from the one from my app realm, so my application gets a bit confused, right? In the code itself, you basically choose the one that you're currently logged into. You can be logged into both of them, actually. And yeah, it's just a pain in the ass. That's why the client app method, it doesn't work that well. However, if I log in to app, but then I use the second approach, so the one with federation, like I told you. So my identity provider takes care of the work, and I click log into federation realm here. It says here federated, right? So now I'm in Bob's world, in Jim's world. So if I log in as Jim, then suddenly it says, okay, I'm Jim, fine, and this is my stuff and so on. Why? Because it knows automatically how to map the information that I'm logged in through, let's say, a social account, right? And put it in a token that looks exactly the same as it does for all the other things, right? So that's why it's very useful and important to do this kind of brokering stuff. If you do the heavy lifting at the IdP level, then it's going to map all your stuff here. Okay, that's it for this small demo because I don't want to go into all the details right now until we actually talk about the patterns which are more related to internal things, right? Like stuff that you can control from your application. So we have here authn and authz, right? If you don't know, authn means who am I, and authz means what can I do, right? So, and we're going to talk about 3 patterns and explore one of them more in detail because, again, 40 minutes. So the first one is about validation and token distribution strategies. Then we're going to talk about centralized login, and then per service / domain authorization, right? Now, there's 2 ways of doing authorization in your services, right? You log in, and then let's call this thing a service boundary. So we have this little dotted line over there. You send the JWT token down, and then you can send it down further into your application architecture, right? So you just proxy your token further on, you just send it onwards, right? That's sometimes maybe it's a good idea because then you can do the validation inside each of the services. So you're sure that the JWT token is valid, it contains certain claims. You can do it yourself, right? You're decentralized in some way. You don't rely on a central server. What's the problem here? You can't revoke JWTs. So if you have a very sensitive application, like, I don't know, a banking application or whatever, and you get the JWT token somewhere downstream, you're going to be like, yeah, looks good to me, you know. But that's not always the case. Maybe you want to revoke the token, and unless your server actually goes to your identity provider and asks, is this JWT token valid? Then you're going to be living a lie, you know. You're going to be living in your service and saying like, yeah, actually, this is completely fine. Here you go, transfer 10 million bucks to that account, and then it's totally fine. The second approach is, let's say, multi-layer. So you get the JWT token from your front end, for example. You send it down to something which does a conversion. You convert that JWT token into something called an opaque token. Have you used opaque tokens in your applications? Yeah, 5 people. So maybe more of you will after this. So opaque tokens are great because then once you pass them down into your services, your end services, which are inside your firewall, let's say, they don't know anything about the user. What does that mean? Well, basically, an opaque token is what it means. It's just a string. You pass the string down, and then you use that string to verify what claims you have, or actually even better, to get the claims that you have. So that gives you a lot of power through this protocol called auth to token introspection. It's an RFC, right? So basically the whole point here is that once you get the opaque token, you don't know anything about the user. So every time that you want to get the claims of the person, you call this introspection endpoint that lives somewhere. It could be in your IdP, it could be in the gateway itself, it could be anywhere, right? It's something that gives you information about who you are. And Important slide here. If you're using JOTs, it's great for decentralized validation. You have less moving parts. But every service will handle different IdP quirks. Like I was saying, you need to map tokens and crazy stuff like that. The token can grow a lot, right? Because you're passing down things, and you can't really change it, right? It's immutable, the JOT token. So what do? You keep sending it down. So you want other services to know what kind of roles you have in those services, and so on and so forth. So you can imagine that at some point, the more your system grows, the bigger your token gets, right? So you're going to be slinging around these huge things that are publicly readable, right? So if somebody catches your token, you're going to be like, yeah, but you know, it's by design like that. Yes. But JOT tokens contain email addresses, usernames, things like that, right? So it's still kind of a security concern in some way if you let people access these blindly, right? With opaque tokens, it's awesome. You can revoke them easily because you're calling something, and then if it says that, okay, this is in the revocation list or whatever, we're going to get rid of it. You can't really leak any data with that token, and you can also do interesting things like dynamic claims. Once you call the server, depending on the time, for example, you return different things. The con is that you depend on kind of a centralized auth server, right? If that thing is down, then nothing will work anymore. And it's also pretty hard to debug sometimes. Now, one of the other patterns that we're just talking about, because we're not actually going to be implementing anything like that now, because we don't have the time, it's backend for frontend, right? So this is quite easy. I guess you've probably seen it if you're doing single-page applications. Yes, 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 yes. Okay, some, maybe. So if you're doing a single-page application, you can just do the authentication and everything from the browser, right? Which is nice. You get the token, then you send it down to all your API calls. It's amazing. However, you need to handle all that logic on the front-end side, right? And then do double validation in the backend. A more elegant approach is actually just having your SPA somewhere living together with your backend server and to do the authentication and authorization from that side. So from the backend that is built specially for the front end. And then you just use cookies to actually handle the session state and so on. And then from there, you talk to the API. You proxy the calls. It's very useful. It allows you to, well, it reduces your attack surface a bit and so on. So it's nice to try. Now, another thing is per service authorization layer. So I was saying before that opaque tokens have an inherent problem, the fact that you're using a centralized server to verify who you are. But that doesn't prevent you to split this domain information into multiple domains, right? So you have an invoicing authorization server, one for HR, one for whatever, right? So then if one of them goes down, that doesn't mean the whole thing goes down, right? Because they can't check tokens and so on. And you can also play around with caching and all that. So that's just a kind of side note, right? Now, before we actually get into the code, I'm going to be talking a bit about how we put all of this together, right? And we have a, let's say, lab setup. So I'm user that goes to my application. That one does the authentication on my behalf. Gives me back a JOT token. I can also federate to another realm there. And with the JOT token, I send it down to an API gateway. That API gateway is built with Spring Cloud. And Spring Cloud is then basically deciding, based on the endpoint, if I'm going to just pass the JOT token down. So one of the first example. And the second one is just taking my token, mangling it, storing it in some sort of cache, and passing down an opaque token, right, to the downstream service. And this can grow as much as you want, right? So it's as scalable as, well, your gateway can handle calls at the same time. And the opaque tokens, in this situation, they call the introspection endpoint in the gateway. So they go up one step, and they ask the gateway, hey, who am I? And you'll see exactly how that works. And behind the scenes, it looks a bit like that. So when the JOT gets to the gateway, it transforms the JOT to an opaque token. It puts it in a cache, and then it sends it down, saying authorization better opaque, right? So that service is not insecure, right? It's still kind of doing something. But then once it gets to the security layer of service A, then it goes back to the introspection endpoint. And well, the protocol also says that you should use basic auth or like any kind of API key kind of authentication to figure out that you're actually calling from an authorized service, right? Because otherwise you could introspect, you could basically avoid the whole security thing, right? Because you steal somebody's opaque token and you call the introspection endpoint, right? And that's it. But if you don't know the internal secret, then you can't actually call the introspection endpoint. So that's pretty cool. Let's have a look. Like I was saying, we have a few things going on here. We have a gateway application, the auth client application, and the same application, so the resource server application, but divided in two. One is with a JOT profile, and one is with the opaque token profile. Let's have a look at the code a bit. Starting with the auth client, maybe. So the auth client is the one that you've just seen in the previous demo. So you just, where am I? It's this thing, which basically does the call to the gateway, right? How does it do the call to the gateway? Well, it figures out, okay, I'm logged in as this guy, which comes from the JOT token, and then I figure out who, like, to which client am I authorized, because we did this crazy federation stuff at the level of the application, if we want to, and then we call a gateway, right? With the same token. Once we call API JOT hello roles, and the other one is API opaque hello roles, right? And inside call gateway, basically here, there's just bearer auth token, and yeah, very simple stuff, nothing fancy going on there. And once we get them back, then basically we just populate the two roles that my two underlying servers see, right? So one of them looking at the JOT, one of them looking at the opaque token. When you go to the gateway, then basically it's just Spring Cloud Gateway, and basically here it says, okay, if you're calling the JOT service, so basically anything which matches API JOT then you cut the first two parts of the URL so that it routes to the right thing in the other service, and that's it, and you send it forward. With the opaque token, you do it a bit differently, right? So you take the JOT token and you convert it. So you can use a filter for that. I call this one opaque token relay filter. And basically what you implement is the filter method, which takes the request and then has a handler function, which is very similar to the filters in any other Spring stuff that you might have seen. We check a bunch of things. And if we're happy in the happy path, right? So we have a JOT authentication token. We get the token, which is just the thing with the claims inside and so on. And we create an opaque token. What's the opaque token in this situation? It can actually contain information if you want, right? But it's a random UUID, right? So it's whatever you want. And we store it. To store it, we just put it in a cache, right? With a couple of the things here. So the subject, which is the person that's logged in, when it was issued, the expiration date, and so on, in a TTL in the cache. So in this case, it means that my opaque tokens, even if I don't revoke them or get rid of them or whatever, they're going to go away in 5 minutes, which is very useful. And we get rid of the former authorization header and we send it down as an opaque token, right? So we put authorization header opaque token, amazing. And the final component, let's say, is the resource server. So the resource server, well, basically here we configure either opaque token authentication or JOT authentication. How? By basically, well, you can do it with profiles. In this situation, it's like that. And if there's some sort of URI, then yeah. So here we have two YAML files actually. So opaque and opaque looks like that. And basically, you say, okay, security auth resource server opaque token, and then you need to define these things. So the introspection URI, the place that you're actually asking for your claims, client ID and client secret. Simple. And for the other case, it's auth to resource server, right? So in this situation, it's very easy because once you know the issuer URI it can build everything by itself using the well-known endpoints and so on, so it doesn't need any more information. You just use the issuer URI. In this case, everything is running locally, so it's localhost 8080 realms app. That's where Keycloak is right now. Good. And to configure it, basically, you just have an authentication converter. It's basically the same pattern for both of them. Why? Because now in Spring Security, if you look inside it, everything is converter from something to abstract authentication token. So for the JOT, it's converter from JOT to abstract authentication token, and for the other one, it's well, it's the same thing. Basically, it's you take the introspected token and then you convert it to an authentication thing. Okay, good. Now let's look a bit at how actually everything pieces together, right? So when I don't know who I'm logged in as, so I'm just going to log in again. Logging into app as Alice. Okay. So what happened here? Well, I called the gateway, and then I called the endpoints which were living below, right? So the JOT pass-through says the following thing. I have these authorities, role admin, role normal user, and then this factor bearer thing, which comes from the JOT authentication, and token type JOT. Okay, cool. The other one, the opaque token route, says I'm admin normal user, and it also adds the scopes, but this is something that you can configure by yourselves to do whatever it wants to, right? Now, each of these endpoints, they actually, 82, or, wait a second, 9001, okay. So each of these, they actually have Swagger endpoints, so we can kind of do what the gateway does and skip that part to see how everything fits into the picture here. When you go to the JOT resource server, it's super simple. You click authorize, and then basically it does all the login for you. So if I click authorize here, you didn't see it. It was too fast, but actually it went to Keycloak, came back. I have a token, and I can use that token actually to see that it's a valid token, right? So it's, yeah, I'm calling the hello endpoint. So if I introspect this token, well, just looking here. Any moment now. Come on. Oh my. Okay, while this loads, we can actually do the following thing. We can go to the other guy. It has the same endpoints because it's the same application, just authenticated differently. Here, it expects me to paste something, which is the opaque token. So I'm just going to put, I don't know, 1, 2, 3. Oh, God. 1, 2, 3. Authorize. And I call the hello endpoint. 401. And it says here, actually, there's more information. It says, better error, la la la, invalid token, provided the token isn't active. The spec says that you need to return at least one claim in the introspection, active, true or false. If you return false, which this thing does if it doesn't find it in the cache, because 1, 2, 3 is not there, it's going to just say it's not active, right? So how do we actually get past that issue? I can actually take this token, because this is valid everywhere in my system, right? This is a token which says it's me. I can talk to everything. And I have a kind of fake endpoint to prove the point. So in the gateway application, we have an opaque login controller, which is very not standard. We can actually debug it to see what happens there. So, okay, cool, debugging, perfect. So I have a very simple script which basically calls the gateway, because I put it in the gateway, the endpoint. It calls opaque login and with the bearer token, right? So in this situation, I just paste the one that I had there. I run it. Amazing. We're stopped in a breakpoint. Now, what do we have here? Well, we have the JOT auth, which is basically the token that we know from above. It has some things there and so on. If you want to see the token value, you can also do this in Spring, which is awesome now. You can click on the view on the string, and then you can actually see the claims inside it. Pretty useful for debugging. And we do basically what the other part does, the API gateway thing does, right? So we create an opaque token. I can just basically copy this one here. and we store it in the token store, right? Imagine in a real environment, you would use something like a distributed cache or Redis or something, right? So you wouldn't store it in memory, maybe. Because once the service goes down, everything goes down, including all the stored tokens that you have, so not great. Now, coming back to this guy here, to the opaque token resource server, if I log in again, well, log in. If I add this to my authentication call, basically, the opaque token, I can, well, basically I can call hello. And then it says hello, so it's all good, right? But what happened? Behind the scenes, whenever I call the endpoint with an opaque token, actually there is this thing going on here. Introspection, like I said. So the introspect endpoint can be, well, it's just a normal endpoint that accepts form URL encoded. When I call hello in my downstream service, it's going to go back to the gateway and says, okay, hello, hello, but who are you, right? So let me find out. I use the opaque token to basically look up in my token store what's going on there. Don't worry, you're going to have access to the code on the last slide, so you can go through it comfortably. And basically, yeah, we have each of these attributes stored in the, this is basically a copy of the JOT token. You see the advantage there? You can take a copy of the JOT token, but you can also add whatever you want inside that part, right? So if you generate an opaque token through your gateway for a specific service, then it's going to contain credentials plus whatever extra stuff you want on it. Imagine you can do user impersonation in a highly distributed environment and things like that, while having full control over this thing and keeping it secure at the same time, right? Okay, so this is the token here. And what happens then is like, okay, I put active true, right? Most important thing, and then I put all the other things that come from the token just to have a couple of things going on there, right? And then it goes back to my application, and my application is all happy dandy, right? In the resource server for opaque token, sorry, it's already in debug mode. So I can put a breakpoint here in the hello controller, well, the roles controller in this situation. It's called hello for historical reasons. If you put a breakpoint here, it doesn't stop because this is, the UI is lying to me. It's not in debug mode. Or is it? 9002. Let me just rerun this, rerun that. Okay. Going on there? Why is it saying unauthorized now? Okay. Bob. Okay, it stopped somewhere. Okay, never mind. Now it's good. So no for one for some reason. So when it gets down to the opaque token server here, we have a bearer token authentication, and this already contains all the claims, right? Because the heavy lifting has been done behind the scenes by the opaque token introspection stuff, right? So basically it went to the gateway, it got the claims back, and they're all nicely packed in this bearer token authentication. The objects themselves are a bit different, but they all inherit from abstract auth to token authentication. Abstract, oh my God. Abstract auth to token authentication token. So that's what it is. And in this situation, it's a bearer token authentication. If I stop this guy, or actually, if I run this guy normally, and I run my JOT thing with debug mode, it's still gonna be, well, one of the things that inherit from this. but not the same, right? So in this situation, it's a JOT authentication token. So it's not a bearer authentication token, right? Pull up the class diagram if needed. Otherwise, basically, that's kind of it. Everything comes together very nicely, and you can continue doing this. You can also pass the opaque token down the stream as well. So you can kind of do what we did with the JOT token, just have mini sub-gateways or whatever. Go complicated, right? Because otherwise, why would your company actually keep you, right? If you're not building a complicated infrastructure. All right. Now, some key takeaways before we end. Use JOT everywhere, maybe. But in some sensitive environments, it's good to have opaque tokens. Again, you have a lot more control than with JOT tokens, so it's something interesting to try. Hybrid is also a very good thing. You do JOT at the edge and opaque tokens internally inside your services. And there are some pitfalls, right, which we haven't gone into great depth and detail, but for example, make sure you do sensible TTLs, because if your opaque token absolutely never expires, that's also a big issue, right? If your gateway dies and it's a single point of failure, that's also an issue, right? And then there's also observability auditing. Now you're in a distributed environment. You're a big developer now, which means you need to understand what's going on at every layer in your services, because otherwise you're going to be in a very weird situation when audit comes and they're going to be like, so what are the roles that you have in microservice 253? You're like, I don't know, I'm going to need to debug it to see what's going on there, right? Not very professional. Make sure you know what's happening in your systems before you actually have an issue. For Q&A, we have a couple of minutes, I think. Otherwise, feel free to connect with me on anything. There's two links over here. There's the code, the slides, and then if you want to rate me, this is like a QR code to send you to the schedule, but you know where the schedule is. Thank you very much. You have 3 minutes to ask me questions if there's any. Questions in the room? Anyone? Oh, yeah.
Hi, thanks for the presentation. Could you say any best practice for logging out?
For logging out?
Yes.
Well, technically, there's a single logout provided by OIDC. So if you're using OIDC, which you probably should, then there's a single logout thing going on there that allows you to, if, for example, in Keycloak, it's implemented in such a way that you can call the logout with a certain parameter which logs you out of everything in your organization, right? And it nukes the tokens and so on. Otherwise, it's kind of a soft logout, right? You log out, but you're not really logged out because the token is still valid and so on. That doesn't invalidate the JOT token, though. So that's why I'm saying, if you log out at the surface, and everything else invalidate your opaque tokens which are associated with that person, for example. Yeah. Thank you.
Regarding the multi-IdP design and the issue of having two sets of claims to maintain to the whole app, could we just implement some transformation logic to an interceptor level to have a common set for the whole app?
Yeah, it's basically kind of what the filter thing does in the gateway there with the opaque token, right? Because it transforms one token into another. So you can assume it's kind of the same thing like normalizing the claims. The only problem there is that if you put an interceptor like that, you need to kind of export it as a library that all of the services in your organization use and maintain it, right? Because then each and every one of them will do this interception and make sure, unless you're doing it before and then sending the, let's say, common token out. The problem is JOTs are immutable, right? So if you do that with the JOT, then you're going to need to build your new JOT. So if you want to validate that JOT, you're going to need to maintain your keys, all that internally in your application in Spring, which is not that great. Don't do a lot of cryptography and crazy stuff like that inside your services if you can outsource it. Yeah.
Okay, thank you.
One more? Oh, here in front.
Great presentation, first of all. I'd like to ask you, would you use security for, let's say, service-to-service communication? For instance, when you have a front end and you have an API gateway and a kick lock, you use that to get a token and to be authorized to communicate with backend services. But what if a backend service wants to talk to another back service? Do you also use security there, string security?
So I didn't show it in this example, but basically, if I want to make a call from my research server to another instance of the research server, as long as you configure opaque token and it points to the same introspection endpoint, that's it. So it takes 2 minutes to configure security because it can talk to other things. You can just pass down authorization bearer opaque token. It works out of the box. That's another very sexy feature of this thing because if you use token introspection, it's super easy to set it up across many, many services because the heavy lifting of the authorization logic is done in the introspection part, right? And it's just a dumb string for all the other ones. And you can use it to call another service as long as you have the rights. Authorization should be, well, basically, you know, pre-authorized and all these like things that you put on top of methods. This is a concern which should still live inside your service because you, as the person that wrote your application, knows who should access what. Yeah. And those roles get injected from the introspection endpoint. So you call introspect, the roles come back, and then they hit the pre-authorized filter, for example.
Thank you.
Sure, thank you. All right, we're done. Thank you very much.